brownies.
There,
We're
got
gonna
it.
have brownies,
Think that was
tea,
staying.
cookies. And whatever we
Pretzel
make.
salad.
Yeah. Seriously.
All right. So if I go off the screen, tell me. Or what did I say already? Oh, yeah. Up until now, when we found the area under the curve, it was between the curve and the x-axis, right? Now we're gonna have two curves and find the area between them. So, for example, let's say we have something like woo, like that, and this one's like what? Like that. And we'll call this one f of x, and this one g of x. And let's say here's point A, and here's point B, and we want to find the area between them from A to B. So that area right there. You don't even need to do the proof. You could probably guess what it will be. So the area will be equal to what? Come on, someone can just come up with this, I know.
Equal to
Alright, hold on. Let me think about it.
Well, what's the first thing going to be? Integral, yeah, we're going to integrate from A to B.
Of f of x minus g.
That's it. F of x minus g of x.
Wow. Where's my cookie?
Because basically it's like the area under this one minus the area under this one will give you that area, right? And that even works. Like it doesn't matter if one's positive, one's negative. Right? If you had like one up here and one down here. Because if I minus the negative area, won't it add this area down here? And it works out. It works all the time. It's pretty awesome. That's it. There's section 8.2 right there. No, there's
I was like, that's awesome.
Oh, come on.
We'll do some examples now. That's the premise. That's today, right there. That's the whole idea.
So I can stop paying attention now?
No, because I'm going to show you some calculator tricks today.
Oh, I like calculator.
Actually, I just learned it myself. I was like, oh, that was kind of cool. Didn't know I could do that. Just kind of discovered it. But the first two, no calculator. Example 1. Let's find the area of the region between, so area of the region between y equals the secant squared of x and y equals the sine of x. From x equals 0 to x equals pi. Does anyone want to see what that would look like, or can we just proceed without a graph?
I'd like to see what it
You'd
is.
like to see, just out of curiosity? Alright. So secant squared, that's 1 over the cosine of x squared. And sine x. In my window, I'm just going to go from 0 to pi over 4 on x. 0 to pi. And we'll just leave that the same graph. Oops, that's not going to look very good. Wow, that's an exciting graph. If we look at the big picture. All that was looking at was like that little section right there.
That's a pretty cool bit.
So we're not going to do it with our calculator though, we're going to just do it by hand here. So I guess the first part,
Figuring out what to do.
yeah, figuring out what to do.
Does it matter
Integral from
which
zero
one you
to
use of
four.
f of x?
Yeah, which
Yeah,
one does
it
matter?
matters which one goes first. That's what I was saying, that's the first part. You got to figure out which one's on top of the other.
So then you
below
should graph
secant
it.
squared. So
How do you
Sine
know?
is lower.
How? You know that.
because you should.
Because we just drafted it.
Yeah.
Okay, if I should have done that. I didn't even think of that. If I didn't show you, how would you figure it out?
You would plug in a point
Just plug in a point, yeah.
and see which one is higher,
Yeah.
which one has a higher y
What's-
value.
I
And
mean-
plug in 0, well, probably not 0.
Yeah, plug in 0. Sine of 0 is 1, right? Sine. Oh no, sine of 0 is 0. Ah, yeah. Sine of 0 is 0. So if I let x equal 0, the sine of 0 is 0. Secant squared, that's 1 over cos squared of 0. Well, the cos of 0 is 1, right? So this is 1. This one's 1, that one's 0. This one's on top, right?
So then you subtract sine from the secant squared.
So then, yep, integrate from a to b. Put that one on first, minus the other one. So here we go, from 0 to pi over 4.
So upside down.
Secant squared of x minus the sine of x dx. We could break this apart into two separate integrals if we needed to. We could go 0 to pi over 4 secant squared of x minus 0 to pi over 4 sine of x. But we don't need to.
Yeah, that's subtraction.
Yeah, it's subtraction. So what's the antiderivative of secant squared? Minus, what's the antiderivative of sine of x?
Plus cos.
Oh, a plus cos. Nice, Bradley. All right. Freaking beast right there. From 0 to pi over 4.
She worked that out in your head like 5 minutes ago. She's just been waiting to say it.
And so we plug in pi over. So we got tan of pi over 4. Think you can do this in your head?
No, I really can't, so how?
Yes, you can, Nicole.
No.
I will talk you through it. Minus tan of 0 plus cos of 0. You can do
This is
this.
not
Or
possible.
we can just use a calculator.
All you gotta do
Yeah,
is
I
picture this in your head.
I don't know that.
Okay, well,
Hitting the head.
need to. At pi over 4, those are equal, right?
Wait.
Because it's halfway there, so it'd be a 45-degree angle. Sine and cosine are equal.
Pi over 4 is in the middle of pi over 2.
Yeah. So that means sine and cosine are equal.
Ends up being 2 over
So
2.
tangent is sine over cosine, right?
So that's 1.
So that's 1.
1 plus the square root of
Plus. Oh yeah, that's ugly.
For 2 over 2.
Root 2 over 2.
We're not going to be able to do this.
Minus
1.
tangent of 0.
0. No, it's 1.
Because it's
It's 0.
sine, it's 0 over 1.
0 over 1,
Not
so it's
positive.
0
And cos is 1.
plus 1.
Ah.
So 1 plus root 2 over 2
So
minus
it's
1.
2 plus.
So it's just root 2 over 2.
That's root 2 over 2. Units squared, whatever the units are.
Who cares?
That's the area
Why-
between those two
Why
sections.
squared?
Because it's
It's area.
Okay.
It's all engineer square inches,
Yeah.
square feet.
Very cute.
Area is two-dimensional. Let's go this way and this way. Easy enough. Okay. Here comes example 2.
Stupid units.
In your homework, I tried to avoid trig functions. Find the area of the region. I don't feel like answering that. Enclosed
Hey, I'm trying to draw the units.
by.
The chocolate question.
Not really. No.
He's teaching right
Sorry. No.
now.
Because we gotta finish
He's
this.
polyopsis.
You're fired now.
That's super.
Ah, he went back and he read the letter. So find the area of the region enclosed by the parabola and y equals negative x. That's it. That's all I'm telling you.
Is this calculator?
No.
This.
No calculator.
Parabola. So is the first one the top one?
I don't know.
You have to say equal to 0, right?
You can pick any number and plug it in for x. Then
And
figure
the
out.
one that's the biggest number.
Well, you want to pick a number though that's in your region that you're looking at.
Well, you didn't give us a
We
real
don't.
number.
You didn't give us-
Oh, I didn't give you a region.
Oh,
Oh.
that means there's
So
no region.
there's-
That means they intersect.
Oh.
How do you know?
Because it's right there.
This guy is
Cheater.
cheating.
Stop cheating. Close your book. Yeah, I didn't give you a region. It says enclosed by the parabola, so they intersect. This line and this parabola are going to intersect. What do you know about this parabola?
I'm just using my resources.
We
It's ups-
know that
It's
it's
upside down.
It's upside down.
negative.
It shifted up.
And that's a line like they're going to intersect, and that's going to be our region that's enclosed by them. So how are we going to figure out our?
The region is,
Yeah, how do we figure that out?
we need to graph it.
Point of intersect. We don't need a graph. Point of intersection. Remember how to find the point of intersection of two functions?
inflection.
Point of intersection.
No, they call
Old
it.
school.
Okay.
Algebra
Where
2.
they cross each other.
Or even algebra 1 with
Isn't
lines.
it y1 minus y? No?
That's the
Y'all
slope.
are crazy. Set them equal. It's point of it. It's where they're equal, right? Point of intersection. It's where they equal each other.
Okay.
I totally forgot algebra 2.
I don't think we ever learned algebra.
That was like 2 years ago.
So 2 minus x squared equals negative x.
So 2 equals.
I'm going to add x squared because I like my x squareds to be positive. Add x
You're
squared.
setting them equal to each other.
Correct. Yeah.
Okay. 2 minus
So now I have 0 equals x squared minus x minus 2.
How do we know that they intersect?
X.
Well, I don't for sure,
Dude.
but I'm checking that right now.
Just
I'm thinking that it's an upside down parabola and a line, and that they're going to intersect like that. But it could be an upside down parabola and a line above it, and maybe they don't intersect. How will I find that out? If this has no solution, if this has no real solutions, then they don't intersect.
It's at negative.
Yeah, but
That's
that's
at 2 and negative 1.
do that. You have to add X squared.
You need to find the.
Oh.
You need to factor that.
I
Right?
would
It's 2
never
negative.
make
Factor it,
X
yeah.
plus X squared minus the same
x
way.
minus 2, x plus 1. Hey, it's factorable, it's solvable. X equals negative 1 and x equals positive 2. Now do you know where to integrate from?
2.
From negative 1 to 2. Go in order.
Well, you just say it weird.
What?
When you say that, I get confused.
Now you can figure out which one's on top. Well, obviously you know which one's on top, because if the line was on top, they wouldn't intersect, would they?
No, but we don't know.
But if you don't know that, pick a number in between these two numbers and plug it at 0. So this one would be 0, and this one would be 2. So this one's at the top, right? Does that make sense? So we integrate, we'll have
So the top one is the one that is first, right? So it's
Yeah.
gonna be 2 minus X.
2 minus x squared minus negative x.
And we just
dx.
push plus X.
Or plus push.
I have to always
We're not
put
using our
dx.
calculator on this one.
You
Next
have to
one we
put
will-
dx. You're integrating it. Never mind, that's stupid.
So now we take the adjunct.
We've come so far today. Yeah, now we anti-derivate this.
Anti-derivative.
So that's 2 minus x squared plus x. Okay, so integrate that.
1/3 plus
Negative
1/2.
plus 1.
Ooh, I got that right.
Did you put the 2x?
Yeah, I did. Do you think that that's the easiest part?
Glad you didn't mix derivative with antiderivative. Like, Day, don't do that. The 2 doesn't go away.
No, I've done that before.
I do that. You kind of mix the 2 and do derivative of some parts, antiderivative of others. Really screws up the works.
Can I use my calculator?
Mm-mm.
I'm really not good at fractions and adding.
So practice that.
So practice
2 to
that.
the third. 2 is 4, 2 is 8. Minus 8.
Okay, so 3 times 2 is 4. It's 8 times
10 thirds.
1. This all out loud.
Whoa!
Oh. Oh.
So 4.5.
Or 9.5, 4.5, 27.6. Yeah, I guess I should reduce. I should be proper about it.
7, 6.
Or 9/2 units squared.
I'm just rounding up the 26. You want me to?
Well, that was fun with no calculator. Let's use a calculator. Ready? Ready or not? Here we go. Calculator.
Okay, so now we're going to use calculator.
Find the area of the region enclosed by.
Continue.
Y equals 2 cos of x and y equals x squared minus 1. This is a calculator problem. I'm going to walk you through this. What's the first thing we need to figure out?
Which one's on top? Which one's on bottom?
So do we just
Actually,
add
no,
up?
that's not first.
We need to
In this
find-
case, we actually need to figure out something else first.
Points for the section.
But yeah, because then on top, because they could change.
Yeah.
It could, you know, they could swirl all around each other. So depending on what point you pick, you want the point you pick to be in your region that you're looking at.
Did you like sign us up for something online?
Me?
Yeah.
No.
I just got an email from, it says Riley, we taking AP this year from the advanced placement program. They're like, we would like to help you prepare for this and how to get your scores in.
Oh, I'm going to try to sell you something.
I'm not running.
Anyway, let's do this. We're running out of time. Area of this region. Okay,
Not listening.
we're using our calculator. We want to find where they intersect first, right? So I'm going to graph both. 2 cos of x and x squared minus 1. Now here's the key thing. Well, okay, I guess I can throw my graph up there. Alright, there's what it looks like.
Yo, how do I
It's
zoom
an
out?
awesome graph.
This is Zoom 6. You're golden. So we're trying to find the area of the region enclosed by them. So right in there.
I do not get some graphics.
Are you in radians? So basically, we're going to integrate from wherever that is to wherever that is. Which one's on top?
The coast
graph.
X.
9 radians?
Wait, what?
That's definitely cos of x on top, right? In that region, I could tell just by looking at it. And that's my parabola.
1 radian?
So this one's on top, and that's my y1, right? So y1 is on top. This one's on bottom. That's y2 on bottom. So now I'm just going to show you how to go straight
How do you know
calculator
it's
on
on
this.
top again?
I just looked at the graph. That's the cos one, right?
Yeah.
Okay. So now to use the calculator, I'm going to integrate from that point to that point. Well, I got to find those points. You know how to find those points?
You have to find the.
Yeah. Second calc,
I don't know.
or second trace.
Where's
Uh,
the calc?
5.
Yeah, go to 5, intersect.
Wait, where you at?
Second trace, right here.
Table? Trace?
Yeah.
Wait, you can find the derivative.
5?
Intersect 5.
So you hit that.
Intersect.
First curve, it's just going to just hit enter. It'll switch to the other one. Second curve, hit enter. Guess. I'm going to go over here and I'm going to guess my left. Do the left one first. It'll make sense. Hit enter. And it tells me x equals negative 1.265424. I don't want to round, and I don't want to write down all that crap. So here's what I do. Everyone got this?
My calculator.
Micah, what are you doing?
What?
What are you doing? Playing Frogger?
Oh.
I don't want to round, I don't want to write that down. Because when I integrate, that's going to be my number on bottom, right?
Yes.
So here's what I do. Just second, quit. Down here there's a button that says STO. That means store. It's going to store your last answer into memory. And it's going to take that value that it's just found, and then it's going to put it, and you need to type a letter in. See the green A, B, C, D, E, F, G?
Yeah.
I'd pick A. So I'm going to store that value as A. And I hit enter, so it saves A as negative 1.26.
Oh, mine's not negative.
Wow.
Mine's positive 1.26.
Did you do the one on the right?
Yeah.
Yeah, you got to do the one on the left first. Well, you're fine. You just need to remember when you integrate, you're going to want that A on top. My A is going to go on bottom. That's my left one. Put your A on top. Because then you're going to go back to your graph, find the other point of intersection, and save it as B, or whatever letter you want. So calc, intersect, first curve, second curve. Make sure it's the other one. Quit. Store it.
First curve, so go back up to that top thing?
That first curve, second curve, it'll do that automatically.
It didn't.
You should just, it'll say first curve question mark, and you hit enter, and it should switch to the other one.
Second quit. And then you click.
So now it's positive.
Okay, so now it's, yeah.
So then once you've got your A and your B, make sure you know which one's going on top of yours. Now, here's the cool part. You just go math, you FNINT it.
You do.
Y1's on top, Y2's on the bottom. So I'm going to go Y1 minus Y2.
I
So,
wondered if we were looking at using anything more.
so go to your vars, Y1 minus Y2, comma, with respect to X, comma. And on mine, it's going to be from A to B. A, comma, B.
Wait. Wait. You do the bottom minus the top, or you do,
Whatever your function that's on top, this
Yeah.
one was Y1.
I'm talking about A and B.
Oh, my A, it's from negative 1.26 to 1.26. So whatever letter you
Oh,
saved,
it's from, okay, got it.
mine was from A to B. Yours might be from F to U if
So
you're
it's
not
pretty-
having a good time.
It's basically 5 units squared.
It's 4.9949. Basically 5, but let's not round.
4.99.
Or 4.99, yeah. So that's how you use your calculator to do this.
That's much easier.
One more thing. What are you doing? We may have to be a little late today.
No.
Well, that just gives me reason to let you out early other days.
Hungry.
If he ever catches us, be like,
I'm gonna get food in the cafeteria. stay blind.
This will be quick. Gosh!
Good afternoon. We
Hate
have
that.
some announcements.
They don't want us to work.
There will not be a Leo's Club Talent Show on February 28th.